Hello, for this video we've got a cable and we've got a tension in a cable and we're asked to break this down into X, Y, and Z components. For this we're going to use the ratio method rather than the standard sines and cosines, just because it's going to be a little bit easier. So what we have is a 6-meter tall pole, and that pole is, the base of the pole is 2 meters out from the x-axis, so it's 2 meters in the z direction. And it is 3 meters out from the z-axis, and that's in the x direction. So we know these dimensions. We know the top of the pole is tethered back to the origin point here. And so step one in finding all these ratios is we need to find the length of this cable. And so I need to find the distance from the origin point up to the top of the pole, and that is going to be my length. And so my length, I'm going to use the 3D version of the Pythagorean theorem. And so L is simply going to be equal to the square root of the x component, so 3 squared, plus the y component, which is 6 squared, plus the z component, which is 2. And square that. Alright, so if I solve this out, I find that the length of the cable just happens to be 7 meters in this case. And that's going to be important in our ratio format. So now we want to look at the tension in the x, tension in the y, and tension in the z. And so Tx is going to be equal to the ratio of the length in the x direction times the magnitude of this force. And so in the x direction, I'm going backwards 3 meters. And so I've got -3, my length in the x direction, over the total length of this cable. And so the total length of the cable is 7 meters. I multiply that ratio by the magnitude of my tension force. So I multiply this by 3 kilonewtons, and if I do that calculation, that will give me my tension in the x direction. And so this is negative 1.29 kilonewtons. And you want to be really careful here that you get the right direction. So I could say, you know, the length from here out is 3 meters, but if I look at this tension force here, I'm going to start where the force is applied, and I go 3 meters that way in the x direction. So make sure the directions match up, and you can kind of double check just by visually looking to see which direction the tension's in. Alright, so that's 1 of 3 for the y direction. So tension in the y direction. In the y direction, I'm going down 6 meters. So -6 over the total length from here to here. That's going to be 7. Multiply that by the magnitude of my tension force, 3 kilonewtons. And that will give me -2.57 kilonewtons. And so the y component of this 3 kilonewton force is -2.57 kilonewtons. Finally, in the z direction, I'm going back 2 meters this way. So -2. My total length of the cable is still 7. And I multiply this by the overall magnitude of the tension force, which is 3 kilonewtons. And so for this, if I multiply the numbers out, I get -0.86 kilonewtons. Alright, so now I've got the x, the y, and the z components of my tension force up here. So I can rewrite this in vector form. So that tension force is equal to -1.29, -2.57, and -0.86. The units are going to be kilonewtons. So with that, we've broken our magnitude, and we kind of had the direction through these dimensions. We've broken that down into x, y, and z components for our force vector. Thank you for watching, and I hope to see you again.